Welcome back to AI Podcast. Today we're talking about WebPilot, a new web agent system from AAAI 2025. Short version? It pairs big picture planning with targeted tree search style exploration, and that combo makes it much better at getting real tasks done on actual websites.
Nice hook. So, who's behind it?
Led by Zhang with Volker Tresp and colleagues at LMU Munich and the Technical University of Munich. Big Agentic Systems Group, very applied.
Got it. When you say better at getting things done, what's the core problem they're solving?
Think of a web agent trying to book travel, edit a wiki, or find a repo issue on GitLab. The web is messy, partially observed, and constantly changing. A lot of prior systems lean on rigid, handwritten policies. Those work when the site looks familiar, and then they face plant when the layout shifts or an extra login wall appears.
Right, the classic demo works until the page moves one button.
Exactly. On the flip side, some agents just search everywhere, like opening every door in a maze. That wastes time and misses the bigger plan. WebPilot's idea is to do both. Plan like a traveler with an itinerary and explore like a local who knows which side streets are worth checking out.
2 levels then, high-level planning and low-level exploration. Walk me through it in plain English.
At the top level, WebPilot makes a rough plan by breaking the goal into subtasks. That's their hierarchical task decomposition. After each subtask, it pauses, reflects on what actually happened, and adjusts the plan before moving on. If a login didn't work, for instance, it revises the strategy instead of bulldozing ahead.
So it's like a project manager who replans after each milestone.
Exactly. Then the local level kicks in. Here they use a customized Monte Carlo tree search. Picture a scout exploring the next few clicks, leaving breadcrumbs about what looked promising. 3 tweaks matter. First, it steers towards states that look goal-relevant, not just random branching. Second, it uses reflection as it expands the search, so early feedback changes what it tries next. Third, when it bubbles results back up the tree, it doesn't average everything together. It keeps the best signal, prioritizing the most promising path.
That last one feels like a common sense rule we all use. Don't average your good ideas with the dead ends.
Exactly, and they add a neat scoring idea. Instead of a binary success or fail, the agent gives itself a 2-part score after each step: how effective the action was right now, and how promising the resulting screen looks for finishing the subtask. It's like points for the shot you took and points for the position you set up for the next play.
I like that analogy. What did they run this on?
2 benchmarks. First, Web Arena, which is a realistic suite of sites across things like CMS, Maps, Shopping, Reddit forums, and GitLab. Second, MiniWeb++, which is more like micro web tasks. One important detail: WebPilot uses text-only observations, basically the accessibility tree of the page, not pixels.
No screenshots, just the text structure of the page. That's harder than it sounds.
Totally. For models, they try GPT-4 and GPT-3.5, and they keep the search budget modest per subtask, so it's not just brute forcing the web.
And the scorecard?
On Web Arena with GPT-4, WebPilot lands around 37% task success, which is a big jump over a concurrent tree search baseline and slightly ahead of a strong policy library system called STP. With GPT 3.5, it still holds up respectably, roughly 29%. On MiniWeb++, it's essentially state-of-the-art territory, within a whisker of the top result, even though it relies on just a handful of high-level demonstrations, while competing methods use more fine-grained action demos.
So the headline is, plan globally, explore locally, and you get real gains.
That's the story. And the narrative the authors push is that decomposition plus reflection keeps the search grounded, while the local tweaks make exploration efficient in the messy middle of a website.
I'm curious about the agent lineup you hinted at. You mentioned a planner and a scout. Who else is in this little team?
There's a planner for the high-level breakdown, a controller that tracks whether a subtask is actually done, and an extractor that gathers needed info on the fly. Locally, there's an explorer that tries actions, a verifier that checks what changed, and an appraiser that scores how useful the new state is. It's like a small crew with clear roles instead of one monolithic brain doing everything.
That sounds modular, which usually helps with debugging and reuse. Any evidence this structure, not just the big model, is what drives the win?
They do ablations showing that removing the reflection pieces or the controller hurts performance, especially on the more complex domains. And the big improvement over the tree search baseline suggests the custom search and reward design matter, not just the model.
All right, let's poke at the edges. What should listeners be skeptical about?
A few things. First, the whole system is text only, no visual grounding. On modern sites, icons, layout, and tiny badges carry meaning, so the agent may miss cues a human would spot at a glance. Second, reproducibility on the open web is tough. Websites change and model snapshots change, so nailing the exact same numbers can be tricky. Third, cost and latency aren't front and center. Search helps accuracy, but teams care about token budgets and wall clock time.
And I imagine accessibility trees can be incomplete. Hidden menus, modal quirks, stuff like that.
Right, the paper even calls out elements that aren't directly observable and things like invisible dropdowns. So some failures come from the environment representation, not just the agent.
Where does this leave the field? What's the next obvious move?
Two big ones. Add vision in a careful way so the agent reasons over structure and pixels together, and make the rewards smarter. Instead of a handcrafted two-part score, learn a critic or use preferences so the agent's sense of progress is tuned by data. I'd also love to see cost accuracy curves, like how success changes as you give the agent more or fewer rollouts per subtask.
And maybe broader stress tests, new websites, frequent layout changes, or tasks that span multiple sessions with memory and sign-ins.
Exactly, plus more safety rails for high-stakes actions, like verifying before posting or buying.
Let me try a quick summary. WebPilot splits big goals into subtasks, reflects after each one, and uses a smarter tree search to try the next few clicks. That blend lets it beat search-only agents and keep pace with the policy-heavy ones, while staying flexible on unfamiliar sites.
That's it. If you're building agents for the real web, the takeaway is to combine a calm navigator with a curious scout. Plan, reflect, and then explore the promising branches with a reward that values both now and next.
Right, and be mindful of the gaps. No vision yet. Web pages won't sit still for your benchmarks, and costs matter in production.
Well said. WebPilot shows that structure and strategy can lift performance without drowning in handwritten policies. I'm excited to see what happens when vision joins the party.
Same here. All right, that's WebPilot on AI Podcast. Thanks for listening.
See you next time.